In this lesson, we'll be going over displacement and velocity, as well as some other fundamental physics concepts. For starters, let's talk about distance. Distance is the total length traveled by an object in motion. Distance is represented by the symbol d. If the distance between your house and your school is 100 meters, and you walk from your house to the school, then back, your total distance is 200 meters. Simple. Next is position. Position is the distance and direction of an object from a reference point. Position is represented by the symbol d with an arrow over it. Let's say, for example, your house is your reference point, meaning that it is point 0, and your school is 100 meters west of your house. This means the position of your school is 100 meters west. Again, pretty simple. Now that we know about distance and position, let's take a look at displacement. Displacement is the change of an object's position. It is the overall distance away from the reference point. Displacement is represented by the symbol delta d. The triangle in this symbol represents the Greek word delta, which means a change in. We also know that the d with the arrow over it represents position, making the symbol for displacement a change in position. For example, if the distance between your house and your school is 100 meters, and you walked from your house to the school then back, your total displacement is 0, as in the end, your position did not change. In physics, the direction of any displacement is always specified. I'm sure you're all familiar with your standard compass, with north, east, south, and west. These directions are used in calculations, so it helps to assign which are positive and which are negative. What I like to do is make north and east positive and make south and west negative. These rules will help us in the next question. If you move from position 200 meters north to the position 300 meters south, what is your total displacement? Using the displacement formula, we need to subtract the initial position from the final position. Since our final position is 300 meters south, this means that this number is negative. We are also subtracting the 200 meters, which is positive because it is north. This gives us a final answer of negative 500 meters, or 500 meters south for our total displacement. Now let's say that instead, from point 0, you move 200 meters north and 300 meters south. This turns into 200 meters minus 300 meters according to our direction rules, giving us a final displacement of negative 100 meters, or 100 meters south. These examples show how you can either calculate displacement from one position to another, or from the overall distance moved in a particular direction. Next is speed. Speed is the measurement that represents distance moved per unit of time. The average speed of a moving object is its total distance, whether that be in centimeters, meters, or kilometers, divided by the total elapsed time, which can be in seconds, minutes, or hours. Simply, v equals d divided by t. A fly travels 16 centimeters in 9 seconds. What is its average speed? We take the distance and divide it by the time to get a speed of 1.8 centimeters per second, rounding to 2 significant digits. By the way, if you want to check out my video on significant digits, the link is in the description of this video, as significant digits are a very important part for calculations in the sciences, so I suggest you take a look. Diving into velocity, it measures the displacement per unit of time. The average velocity of an object is its total change in position divided by the time it took for the whole motion. The formula for velocity is delta d divided by delta t, and it is represented by v with an arrow over it, showing that it is a vector quantity. Now that we learned about position, distance, displacement, speed, and velocity, it's time to put it all together. A jogger is going for a run at 8 a.m. He first jogs 75 meters north to his mailbox down the street. He returns home and drops the mail off in his kitchen. He then jogs 1.5 kilometers north and meets his friend at his house at 9 a.m. Question A. What is the total distance that the man traveled? The first thing we must do is convert the 1.5 kilometers into meters. That way, we can use it with our other values. This turns into 1500 meters, which we can add to the other 75 meters. However, we are told that he ran to his mailbox and back, so we must add another 75 meters to our total distance, for a total of 1,650 meters. Question B asks for the total displacement. We know that the jogger went 1,500 meters north, and we also know that he made a trip to his mailbox and back, which we could represent in this formula, in which those displacements are cancelled out because he arrived in the same spot that he had left, leaving us with our total displacement of 1500 meters north. Question C asks for the jogger's average speed. We know that we find speed by dividing distance by time, and since this occurrence took place in 1 hour, or 3600 seconds, and we know that he ran a total distance of 1650 meters from question A. So the jogger's average speed is 0.46 meters per second, rounding to two significant digits. Finally, question D asks us to find the jogger's average velocity. Simply, we know that he has a total displacement of 1500 meters north from question B, and that the whole jog took 3600 seconds. So the jogger's average velocity is 0.42 meters per second north, rounding to two significant digits. For those who want more, here are some practice problems that you can try out yourselves. The answers are posted at the end of the video. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing and dropping a like on this video, as it shows me that you like what you see, which helps me post more videos. Anyways, that's it for now. I wish you well, and hope you have a good day.